Hello, everyone. Welcome to Let's Talk Cloud Native Security. My name is Theo Comas, and here with me is Magno Logan.
Hi, everyone. Welcome to Let's Talk Cloud Native Security.
Yeah, in this episode, you will learn more about the new MITRE ATT&CK for containers and how it can help you to be ready to protect your containerized workloads. Magno has been involved in the development of this new framework, and he's going to tell us the details about it.
Yeah, that's right. We will also talk about the pod security policy deprecation and what can you do once Kubernetes does not support that anymore.
Yeah, so let's start. Magno, tell us for people that don't know, what is this MITRE ATT&CK framework? Tell us about it.
Sure. The MITRE ATT&CK framework, as the name says, is an adversarial tactics, techniques, and common knowledge, right? That's why the name attack. It was basically created by MITRE, and it's a globally accessible knowledge base of adversary tactics and techniques based on real-world scenarios, right? What does that mean? Basically, they mapped all the tools and approaches and techniques used by real actors, right? And they mapped that into a matrix, into a framework, right? And they created that MITRE ATT&CK framework.
Yeah. So what makes it different from other frameworks such as the cyber kill chain, the attack lifecycle, and cyber attack model?
Sure. Yeah, the main difference, I think, based on compared to those other frameworks, it's because the MITRE one, it's open source, it's available to anyone and any organization to use for free, right? There's no copyrights, no restrictions on that, and you can also contribute it to the framework, right? You can provide information and suggest new techniques and sub techniques as well. So that's why I think because it's open source and it was created by a kind of independent organization such as MITRE, which has a great experience and great background on dealing with those sorts of information and security, right? They're also responsible for creating the CVEs. And so I think that has become a global standard for every organization and cybersecurity company to adopt it, even in their product as well.
Okay, that's great. So obviously MITRE has been driving this, but who else has been involved in creating this new one specifically for containers?
Sure. Yeah, so the MITRE ATT&CK for containers was created, right? At first, there was a blog post released by MITRE on December 17th last year, 2020. So the blog post was written by John Burns, which is also the lead for the MITRE ATT&CK for cloud and now for the containers as well. Basically asking for help from the community and asking for data and evidence about which real world scenarios were the attackers were exploiting and which techniques they were doing once they compromised those environments, right? So on the next day, on December 18th, our team here at Micro has reached out to MITRE, and we provided information on all the public reports that we released since 2018 that we're doing research on Docker, and we have honeypots on Docker as well, and also our Kubernetes honeypot that we start doing this year and analyzing the attacks as well. Yeah, after that, I think other organizations are involved, and such as Aqua, Sysdig, and Palo Alto, and many others. So they also provided some information to MITRE. And between the December last year and February this year, we worked with MITRE on releasing the first draft, which was done on February 18th. So that's the first draft. I think that's what you're seeing or you're going to see soon. Yeah, that's it. Okay, so this is the first version, right? It's not the official and final release yet, but it's a public release asking for comments and feedback from the community the broader community as well for information. So I think that's really helpful. And the final version should be released on April, by the end of this month in April. So yeah, just stay tuned for that.
Okay, yeah, thank you. And yeah, for the others, why is it useful or important to be aware of this framework, and how can you use it in your environments?
Sure. Yeah, so I think the main goal for this framework is understanding the behaviors of those threat actors, right? Those attackers that may compromise your environment. So behaviors and habits are hard to change. So once you understand those, you can provide some protection and some mitigations against those behaviors that they might have, or techniques and tools that they might use. So I think the main goal for MITRE is okay. These are all the, not all that, but the main techniques or the main tactics and procedures that, threat actors are using to compromise your containerized environments, right? In this scenario, in your Docker environment, your Kubernetes cluster. So now you have just looking at the matrix, you have a clear picture of what they're doing once they get inside your environment and how they do to get inside your environment, right? What techniques and what they can compromise there. So you can this provides you and any other company or organization with specific and actionable recommendations for you to mitigate against those tactics and techniques, right? So you can easily understand, okay, how are they compromising my environment? Oh, it's if you're exposing the Kubernetes API server or the Docker daemon API, right? They can exploit, they can access through that and issue commands to deploy containers or pods, right? So you need to protect against that by not exposing the API server, for example. So I think that's very helpful for any company that are using containerized or clusters, Kubernetes clusters. Yeah.
Yeah, that's one of the main things that I like, because it's based in real world evidence. As you said, you set up those honeypots and you see some activity, and then you gather the data. And there's a lot of times that in security, and mainly in cloud, there's so many cases, so many things that can happen, and you don't know how to prioritize. But here you can see specific ways and guidelines to prioritize and see what is important, because sometimes it can be very confusing for people. And this is where MITRE ATT&CK and this specific framework for containers can help a lot. And where can we find more information, the reference?
Sure. I think the great starting point is this blog post from Jim Burns, the update with the full matrix and all the details why they chose these ones. There are some techniques that are already known by the MITRE community, right? But there are some new techniques there, and they describe why those are important. And there's a lot of reference and links there. And yeah, besides that, there's we're also going to add a lot of all the links that we provided to MITRE themselves with our previous research. We're going to add that to the video description, so you can take a look at that. And if you want to contribute, if you have information about other tactics and techniques that are being used by attackers, by threat actors, either by past events or by information from your honeypots, for example, then you can reach out to MITRE there. There is their contact information on the blog post. If I'm not mistaken, it's attack@mitre.org. So they receive all that information, and you can discuss with them and provide other data directly to them about new techniques and other things that you're seeing on real world environments.
That's great. Thank you. Yeah, and sure, if you have any questions, just put comments in our video or ask us on Twitter about more details, and we will be very happy to reply and maybe make more content for you to be more specific in some scenarios. Yeah.
Yeah, that's great. And yeah, Diego, I've heard that, just switching topics here a little bit. I've heard that there has been an interest update regarding an important Kubernetes security feature, right?
Yeah. So as I'm usually involved as well in these meetings and updates, but also the community can see it in from the public people. So Tabitha Settle, which is one of the Kubernetes security co-chair, she tweeted this a few days ago regarding the what's happening with pod security policy. This has been concerning for some people, and they publicly put these blog posts where they put a lot of information to make awareness of why this needs to change, what are the decisions behind it, what was happening with the previous versions, and the timelines of what is happening. And some people is worried about the change, but this is a really good blog post that can provide a lot of information. And this is a really good blog post with a lot of information, but we can go in more detail about it.
Sure. Let's do that. But first, before we dig deep into that, can you explain to us what is a pod security policy, or PSP for short, and what problem does it solve?
Yeah, so in Kubernetes, a pod security policy is a cluster level resource that controls security sensitive aspects of the pod specification. So translating a little bit more simple words, this is when the characteristics of a pod can be modified, like things, for example, if you want to define that a pod can be running as privileged or not, or if you want the pod to be able to use the host network or host ports. These are special characteristics that can lead to an escalation of privilege and lateral movements throughout the clusters, and this can be worrying. So pod security policy is able to define these specific rules to say, hey, privileged containers should not be authorized. So if you detect that, just block it. And this is pod security policy leverages the admission controllers. So it's pod security policy runs as an admission controller in the Kubernetes cluster. And as I'm a big fan of the admission controls and these kind of features in Kubernetes because I think they are very powerful and very useful. I did an introduction about that in the Kubernetes meetup a while ago, and I also wrote a blog post where I can share it in the links. But basically, the Kubernetes admission controllers are plugins that govern and enforce how the cluster is used. So they can be thought as a gatekeeper. And I'm going to share just a simple diagram of how this works, because I think it can be more easy to understand.
Sure, let's do that.
Yeah, so here we have this diagram where people can see that when a request goes to an API request goes to Kubernetes, then there's a step of the authentication and authorization, but then there's a step where it's the mutating admission webhook. Here, usually, the control is reviewing things that you might want to obviously change. Or, for example, if you detect that there's a specific naming convention that you want to change the labels and annotations, you can do changes in the Kubernetes in the object. And then after those changes, there's a step to validate that everything it's going to be understood properly by Kubernetes and it has the right schema. And then the final step is to validating admission webhook, which usually it's enforcing a yes and no according to other rules. Like this is more like when pod security policy acts. It's like, okay, this is the final version of the object after passing the schema, is I have a rule of do not allow privilege containers, and then here there's something that I've detected, but I'm not going to authorize. And then once it's passing or denied, then it's persisted to etcd. So I think this is very powerful because in a lot of environments, there's a lot of flexibility of things, and sometimes there are mistakes to building the whole template or customize or things like that. And the admission controller is the last line of defense, and it can help you say, okay, although someone by mistake did that, we don't want in the cluster to happen this, and then it will be the last moment where you can catch that if someone is trying to abuse or exploit the pre-configured manifest. And yeah, that's what I like it. And pod security policy leverages admission controllers to do all these enforcements and controls in the objects.
Nice. That's great information. Yeah. And why is it being deprecated? Why this change is necessary?
Yeah, so there's a little bit more information about from the blog post that Tabitha has linked in her tweet, but also there was a really good KubeCon presentation from last year about the decisions of the SIG-Auth to think about the change. If we want to summarize from the information that they also released, is that there were a lot of problems in terms of usability, and that it's hard to change them without the breaking change in the feature. And a lot of people was also mentioning that applying pod security policies, it's confusing, and also it can be easy to grant broader permissions than intended, and difficult to inspect the pod security policies, how they're applied in given situations. In my experience also, I had circumstances where I had existing running clusters that I wanted to apply new pod security policy rules, but you don't want to just apply them in production or not knowing what is going to break and what can change. So with the original pod security policies version, the dry run mode, it's something that was not possible, and it's impractical to retrofit into existing clusters with pod security policies without knowing what's going to happen. And I think that was, it was a big problem for a lot of companies. At least it was for me as well. And as well, some people say, oh, Kubernetes should have more security features enabled by default, but if pod security policy is enabled by default and you don't know what is going to happen, you don't know what to expect in your environment, that can create a lot of pain, because suddenly you might have some unexpected things not working. And because maybe you have a monitoring pod that needed to access the host network or something like that, and then suddenly it's a stop and block, and then all the fire alarms start. So that's why there were multiple reasons that they thought it was necessary, this change. And yeah, that's it.
Okay, and who decided this change, and what do they do?
Yeah, so in Kubernetes projects, there are some special interest groups that govern the different feature of the features of the project and different components. And specifically for pod security policy, the SIG-Auth and the SIG security group has been very involved in that. The main persons has been Tim Auclair, Ian Coolwater, Jordan Legit. There has been more people, but I think this have been the main drivers of the changes and the coordination of what needs to be done. And yeah, usually in those groups of the Kubernetes projects.
Awesome. Yeah, thank you, Diego. I think that's really good to know for everyone out there that are not aware. And just before we close up, just what can you do? Like if you are not aware or you don't know how to use the pod security policy right now, right? And you don't want to wait until the new version is released, what can you do? What are the alternatives there?
Yeah, so there are alternatives available, like for those pains that we mentioned in the past. Alternatives arise, like things like Gatekeeper from the Open Policy Agent project, and also there's things like Hiverno and other alternatives that allow people to create some security rules to manage all those properties of the pods that can be risky. And and if you're not considering those alternatives, the proposal of the new replacement from officially from Kubernetes, it's in alpha, but they're going to release, and people can try it very soon. And the difference is what they mention and recommend is that if you have a simple setup of pod security policies, then it might be fine migrating to the new replacements. But if you have a complex and sophisticated setup and with complex binding rules, then it's very likely that it will be super painful, and they might recommend you to assess what is more worth, if migrating all that to the new replacement or using an alternative like Gatekeeper or other tooling. Yeah.
Awesome. Yeah, that's great. Yeah, that's a lot of great information. Good to know. I think if you want to read more information about it, just please check out the links on the video description below, right? We're going to add all of that on the video description. Feel free to check it out. But also, if you have any questions or doubts, or if you need more information, feel free to add any comments there for us. We'll try to reply all of them.
And it's important as well in the pod security policy, sorry, Magno, about that although they say it's deprecated, it's not suddenly stopping. So there's enough time for people to do it. Deprecated means that they're not going to continue evolving that part of the feature, and there's a replacement, but it's not suddenly stopping. You have until Kubernetes 124, so you have at least a year to keep using it and think about the alternatives. That's something that some people, it's a little bit controversial, because some people think, like when it happened, the Docker team, do you remember?
Yeah. The Docker chain deprecation, right? That caused the kind of a chaos on the internet, because Docker chain was being deprecated, and people thought that, oh my God, Docker is not going to be supported by Kubernetes anymore. I can't use my Docker containers on my cluster, and that's crazy. And yeah, that's not the case. And I hope you are everyone is already aware of that. There was been discussions and some blog posts. Yeah.
Keep calm and keep securing your Kubernetes pods. And there's enough time, there's alternative, and there's multiple choices there.
Yeah. Also, make sure to like this video and subscribe to our channel. There's much more videos to come, and stay tuned.
Stay tuned. See you next time.
Bye.
Yep.